Hello, my name is Joe Schaffer, a site civil and infrastructure engineer based in New Jersey. This video is a reproduction of a talk I presented at the New York City Future Metropolis event on May 8, 2011. In pecha kucha format, I'll present to you two sustainable water technologies appropriate for the ultra-urban environment of New York City. So let's start with a question. What is water? Is it life? Beauty? A problem to be managed? My view is that water is a gift that deserves respect, a basic need for our society that requires thoughtful management. It is the lifeblood of our civilization. Pictured here is Basilica Cistern in Istanbul, constructed in the 6th century. One of hundreds of ancient cisterns in the city, it has a capacity of 21 million gallons. You can see in a world without fossil fuels or heavy machinery, the rainwater was important enough to merit a massive engineering effort and attention to detail. What is truly remarkable about Machu Picchu is its drainage system, which not only controls stormwater, but it was also used for agriculture out in the suburban steppes. The Incans built this by hand without draft animals or the wheel 600 years ago, and it has survived without maintenance for about 400 years. No matter what you call it, humans have been engineering the urban environment for thousands of years. And I'd argue that Machu Picchu is the best example of urban regenerative terraforming in the Western Hemisphere. The 5 points listed above are the basis of engineering and have not changed since the field emerged in ancient times. So, how do we regard water today? Sewer design from the late 19th century until recently has been about moving water off and out and attempting to dominate nature. We have also trained ourselves to think the water supply system has little to do with the sewer system. If there is anything that you take away from my presentation today, I'd like it to be this graph. It illustrates that potable water is a vanishingly small proportion of the Earth's total water supply. Add to this that the total amount of sustainable drinking water supply is even less because of natural variations in recharge and technical supply issues. This is the water cycle, a natural process delivering water from the oceans to the land, surface and groundwaters feeding back into the oceans. It's a dynamic model that is affected by a blizzard of variables. We know from tree ring and ice core data that regional climates change and can tip rapidly. Seeing how water is delivered to New York City, you can envision how this world-class system fits into the water cycle. By 2030, NYC can expect 1 million more people, or a population increase of 12.5%. Although water conservation efforts have reduced per capita consumption, conservation has a practical limit. Take a moment to ponder this question. Give up? Well, for a sanitary sewer, it's about 1 minute into the first commercial break of the Super Bowl, when about half the toilets in New York City flush. It's a design parameter that we use frequently. For a storm sewer and a combined sewer, it really depends. So, can't we just build more pipes? Well, it comes down to money. Installation of a new pipe in New York City can cost between $200 and $500 a linear foot, if it's even possible to make the system work. These are massive, multi-billion-dollar projects that tend not to work unless fully completed. New York City is blessed with very consistent rainfall, an average of 44 inches per year. The small gray bars are the maximum one-day rainfalls, still pretty consistent. 90% of yearly rainfall comes to us in storms 1.2 inches or less in depth. This yields a net balance between toilet flush demand and rooftop runoff for a typical brownstone. If we zoom into the data further, we see that on a monthly basis, precipitation is again quite consistent. This makes the task of engineering a rainwater harvesting system for non-potable uses like toilet flush relatively easy. It's a very promising technology used in more of the arid US states and in the British Commonwealth countries. We've all heard about CSOs. The consistency of NYC's rainfall makes implementation of rainwater harvesting that much more effective in reducing the number of these events. By reducing the stormwater flow to key areas, I would argue that rainwater harvesting can reduce the overall number of CSO events in our city. So you implement rainwater harvesting with a tank, pumps, and treatment. A device like this can fit under a backyard patio. Right now the regulations allow this with a performance standard, but in the next few years I'm looking to help the city change this to a prescriptive standard. Works well in a low-density area, but what can we do in one of New York's famous skyscrapers? We have all heard about greywater systems, where water is collected from lavatories, showers, bathtubs, and laundry, and is recycled for non-potable use such as irrigation or toilet flushing. Technically, this is a downcycling system. The price point of these systems is reasonable, and as you can see from these charts, there is a net balance between greywater generation and toilet flush demand. These systems are fundamentally simple if designed properly. Here is an example from a fortress in the Caribbean where harvested water was used to cool cannons. Today's advanced technology is not necessary, although it can be used for quality control. For a thoughtfully designed system, maintenance is within reach of most homeowners and building managers. When implementing these types of systems, we have to think about signage. Here are some examples from the UK. Just be aware that local requirements may vary from these examples, and as systems are adopted and the technology becomes more widely accepted, the standards may shift. Here is a development in London that integrates stormwater management into an apartment complex to create this water feature. You can see how this creates a riparian vibe for the residents, and could also double as a retention system for water recycling. So you see these systems can also be attractive and hidden in plain sight. I leave you with the cistern at Jefferson's Monticello, which provided emergency water for fire protection. Conserving water is just like saving energy, and in this way, a water harvesting and recycling system is analogous to solar panels. Implementation of these systems in key areas can take some of the pressure off public systems. Thank you.